Okay, the next thing we're going to talk about, we're still in 1-3, which is linear models. We're going to talk about mixture and money problems. Mixture generally consists of mixing two elements or two items together and using their costs per unit to determine a solution. Let's take a look at the first example. It says how many ounces of a gold alloy that costs, that means it costs $320 an ounce, must be mixed with 100 ounces of another alloy that costs $100 an ounce in order to make a mixture, let's see, $100 an ounce, in order to make a mixture that costs $160 an ounce. Okay, so we're basically mixing two alloys together. And so we've got two alloys. We'll call the expensive one the gold, that's the expensive one, and the other one is the cheaper one. And we actually know how many ounces of the cheaper one we're going to use. We're going to use 100. We don't know how many ounces of the gold alloy we're going to use, so we're going to call that X. But if we're going to add these two alloys together, we know that we're going to actually have a total of X plus 100. Because whatever this weighs, how many ounces of this plus 100 ounces would be X plus 100 ounces total. So that's the total ounces. Now the rate, the cost rate here is $3.20 an ounce for the expensive alloy. So that would actually cost $320 times the number of ounces, or 320x. Here the cost is $100 per ounce, but we know there's 100 ounces, so 100 times 100 would be 10,000, so that's $10,000. And then we want it, after it's mixed together, we want it to cost $160 per ounce. So we want the total cost when we mix it, which is $160 times how many ounces, which would be X plus 100 ounces. That would be the total cost once it's mixed together. Now the idea is when you mix these two alloys together, the total cost when they're mixed should be the same as they are before they're mixed. So 320x plus 10,000 has to equal 160 times x plus 100. So basically the cost of the gold, the total cost of the gold alloy plus the total cost of the cheaper alloy must equal the same cost as the alloy after they're mixed. So if we add those two together, 320x plus 10,000, that's got to equal 160 times x plus 100. And then we can distribute here and get 160x plus 16,000. And then if I subtract 160 from both sides, I get 320x minus 160. That's going to give me 160x. And then if I subtract 10,000 from both sides, take 10,000 away from this side, and it's just going to cancel the 10,000. And then take 10,000 away from 16,000, I'll get 6,000. So now I'm kind of assuming that you've mastered equations and you understand, how I go from this step to this step. But basically what I'm doing is I'm just doing it in my head where I'm using the properties of equations. So anyway, I get 160x equals 6,000, and then if you divide 160 into both sides, you'll get x equals 37.5 ounces. And that's the number of ounces at 320 ounces. And that was actually what it asked. If you want to know the total number of ounces, let's see. You actually have, let's see what I did here. Oh, I actually added the wrong thing. The total number of ounces is actually 137.5 here. I think I added it to the cost instead of to the number of ounces. So there's 137.5 ounces. So it didn't ask for that, but I mean it's easy to figure out because if you do 37.5 ounces of gold and then you add it to 100 ounces of the cheaper alloy, then you've got 137.5 ounces of the mixture. All right, let's do another one here. It says how many milliliters of a 10% solution of boric acid should be mixed with 60 milliliters of a 4% solution of boric acid to produce a 6% boric acid solution. Okay, so this is actually pretty much the same as the one I just did. We know we have a 10% solution, and that's the unknown, so that's going to be X. We know that of the 4% solution, we're doing 60 milliliters. I didn't write the units, but it's milliliters. And then, obviously, if we mix X milliliters with 60 milliliters, we're going to get X plus 60 milliliters. And now the rate, we know 10% of X is acid, so the total acid here would be 0.1x, or 0.10 times X. Here we know 4% of the 60 has to be acid. You can actually easily calculate this. Just multiply 60 by 0.04, and so you get 2.4 milliliters of acid out of that. And then, you know, your final solution needs to be 6%, so it should be 0.06 times the total amount of the solution. So 0.06 times X plus 60. This will actually be the acid content of the total solution. So here's the acid content of the 10% solution. Here's the acid content of the 4% solution. And we want that to equal a 6% content of the total solution, which is X plus 60. So we want to add these two together and get them to equal the third one. So if we take 0.1x and we add it to 2.4, that should equal 0.06x times X plus 60. And then you distribute 0.06x times X here, and then 0.06 times 60 would be 3.6. And now our algebra kicks in that we learned before. If we subtract 0.06x from both sides, we'll get 0.04x on the right, on the left, and of course on the right it cancels. And then if we subtract 2.4 from both sides, it cancels over here, and then 3.6 minus 2.4 gives me 1.2. And then I can just grab a calculator and say, okay, what is 1.2 divided by 0.04? And when I did that, I got 30 milliliters. So I got 30 milliliters of the 10% solution. And that's what it wanted to know. But just to show you, you actually end up mixing a total of 90 milliliters, because 30 plus 60 is 90. And what's interesting is you can actually figure this out. If you take 10% of 30, you get 3 units of acid. We know this was 2.4 units of acid, so that's 3 plus 2.4 is 5.4 units of acid. Well, what's interesting is in the total, you've got a 6% solution, so guess what? 6% of 90 is also 5.4 units of acid. So the numbers do work out. Okay, now let's take a look at a coin problem. Here you have a coin bank that has 25 coins in nickels, dimes, and quarters. There are 4 times as many dimes as quarters. The value of the coin is $2.05. It says how many dimes are in the bank. Actually, I think I answered all the questions, but let's go ahead and see how I did it. First of all, I said let X be the number of quarters. The reason I did that is because up here it tells me the relationship of the dimes to quarters. There are 4 times as many dimes as quarters. So if I let X be the quarters, well, I know the number of dimes has to be 4 times that. Because if there's 4 times as many dimes, that means that the number of dimes must be 4 times that. Now, here's the tricky part. I know that there's a total of 25 coins. So if I have 25 coins, and I know that there are X dimes, well, let's take those away from the 25. And I know there's going to be quarters. There's X quarters. Take that away from 25. I know there's 4X dimes. Take that away from 25. And so what I end up with is 25 minus X minus 4X, or 25 minus 5X. So I can use this to represent the number of quarters. Nickels. That's the number of nickels. And now, so I've got x quarters, 4x dimes, and 25 minus 5x nickels. Now, what's the rate? Well, the rate in dollars, I could do this in cents, but I chose to do it in dollars. The rate in dollars is $0.25 per quarter, $0.10 per dime, and $0.05 per nickel. So how many dollars do I have? Well, if you multiply 0.25 times the number of quarters, that tells you the value of your quarters. If you take 0.10 and multiply it by the number of dimes, that's going to give you 0.4x. So that's going to give you the value of your dimes. And then if you take 0.05 and multiply it by 25 minus 5x, that's going to give you the value of the nickels. Well, we know that if we add these three values together, they've got to add up to $2.05. So I'm going to take the value of my quarters plus the value of my dimes plus the value of my nickels, and they should add up to $2.05. Now, if I did this in pennies, this would be 25, this would be 4, and then this would be, this would be 40, and this would be 5, but I'm doing it in dollars. Okay, so now 0.25x plus 0.4x is 0.65x. Lost my x there, looks like. Okay, and then 0.05 times 0.05 times 25 is 1.25, and then 0.05 times minus 5x is minus 0.25x, and then 0.65x minus 0.25x is 0.4x, and then just $1.25, subtract that over here from $2.05, and I get 80 cents. So when I take 0.4x equal to 0.8, if I divide 0.4 into 0.8, I get 2. So I have 2 quarters. And remember, I have 4 times 2 dimes, so that would mean I have 8 dimes. And then remember, I have 25 minus 5 times x. So that would be, remember, x is 2, so 25 minus 10 would give me 15 nickels. And so I have 2 quarters, 8 dimes, and 15 nickels. And you can check this real easy, because 2 quarters is 50 cents, 8 dimes is 80 cents, 15 nickels is 75 cents. And if you add that up, you're going to get $2.05. And notice that the number of dimes is 4 times the number of quarters. And notice that if you have a total of 25 coins, notice that if you take 2 plus 8 plus 15, you get 25 coins. So that's how you would solve that problem. That actually can be solved using 2 equations, but we're not to that point yet. But that's how you solve mixture and money problems. We'll talk about uniform motion problems on the next video.